Hello maths fans, I'm back in Heidelberg, joined by another fantastic guest, and it is my pleasure today to introduce Pat Hanrahan, who was awarded the Turing Award in 2019 for his work on computer graphics. And we're going to start with, I guess, a trip down memory lane, because I had the pleasure of introducing Pat for your Spark session this morning, and you told me of various demos that you've had to do throughout your career for people from all kinds of creative industries. Yeah. So your work has been used in movies, video games, music videos as well.
Yes, music videos.
Sort of images, animations, computer-generated graphics. So let's just start with, is there a particular person, group of people memory where you're doing a demo and you just, you know, you did like a double take, like, am I really doing this?
Yeah, exactly. Well, actually, to me, there was one. So when I started out, I was at this place called New York Institute of Technology, which was this crazy place in Long Island, and was half artists and half, computer scientists. Yep. And the artists, they started making music videos. And so this was like in the late 80s, where music videos were really popular, MTV, that era. So probably, I don't know if that's popular as much these days. But anyway, we did two at NYIT, and one was Kraftwerk. And it was this, which is a German band. Maybe some of the guys, it's an older band, but it's a very famous band.
No, even I know Kraftwerk. Like,
So anyway, what I did is I wrote the software that digitized their heads. So it was like the animation was sort of like talking heads, but they were like line drawings, If you've ever seen these line drawings, you can sort of imagine it. Very crude, just a bunch of lines, but they're talking and singing, okay? Yeah. So, they would come by and we'd take pictures of them, and I would be digitizing their heads and be hanging out. And that, so I was always like writing code, Yeah. And then, if they were doing something, I'd have to demo it or work with them. So that was fun. But the one the really enchanting one was Laurie Anderson. So she came, and she was mostly, we weren't doing a music video for her, she was thinking about doing a music video. Okay. So we were just trying to entice her, like, here's what we could do, And she was just so energetic and enthusiastic and always asked these great questions. So that was probably the most fun one I've had. But I've done lots of other ones, like when I was in Marin County, which was where Pixar was. We had a lot of demos there because we were sort of associated with Lucasfilm. So a lot of people, we were doing computer graphics and they were mostly doing special effects. So all these people would come and be working on movies. So we did all sorts of demos, and some of them would just be like cool people coming by to figure out what's going on, like Robin Williams and Grateful Dead and all sorts of other people like that. So so one of the fun things about it, one really cool thing about computer graphics is there's this other aspect to it, is like you're doing all this stuff with all these creative people, and you're writing all this software, and you're working with artists, because the artists are just like really imaginative, So they see you give a demo and they say, "Oh, can you do this?" And then you say, "Oh, I think I could do that," And then it's just real positive feedback loop. So these demos have always been really fun. Yeah.
Do you find then that working with, as you say, the artists with the creative mindset, that they are actually helping to really push the boundary?
Yes, absolutely.
Of what was possible, and led you into all of this incredible.
Absolutely, because they would want to do all this stuff. Yeah, and they would just fearlessly start using it, because they just thought it was cool. They were really into technology. Yeah, and I don't know if you program. You write your own program and you sort of know what it's going to work and how it's going to break. You know what I mean? You sort of know its limits. And you're sort of afraid to, use it in certain ways because you know it's not going to work. And so you don't even go there. Whereas the first thing they do, that.
They're like, right, what's like the extreme thing we can try, and then let's go for it.
Exactly. So that then it'll break or won't do what they expect, and then you'll just want to fix it, and then it's just this constant. They're just always pushing the boundaries, and also they just the way they think of the world, especially like visual imagery. They're just much more sophisticated about it, and making all these references and and they know the importance of things. Like one project, I worked on rendering faces and hair and stuff like that. But just just they really wanted people's faces to look right. I mean, and I sort of was that, but it wasn't my idea. Like we really have to make people look good. But they really wanted them to look the way they wanted them to look, and So anyway, yeah. So in the early days of graphics, artists collaborations, both at NYIT and Pixar, were just absolutely essential.
As we've been hearing, Pat's pioneering work in the development of computer graphics led to him presenting to a whole host of superstars. And whilst most of us are unlikely to be asked to present to an Oscar-winning actor such as Robin Williams, presentations are of course the norm, whether that's at school, university, or in the workplace. And they can feel quite daunting, especially when you have to create your own slides. Fortunately, today's sponsor Gamma is here to help. Using the latest AI technology, Gamma Agent is your intelligent AI co-pilot for smarter presentations and content. Your Gamma Agent actively researches, edits, and reshapes your content, functioning much like a trusted human teammate. Simply upload your current presentation and Gamma Agent will fact-check it for you, adding sources and hyperlinks automatically. And when you're asked for the dreaded summary of your slides, your agent has your back, condensing a 20-page slide deck to a 2-page summary with 0 manual edits required. As the most popular AI presentation app in the world, with over 50 million users, you can rely on Gamma to make your presentations Oscar-worthy. Head to gamma.app, that's gamma.app, and get started for free today. And just in case you were wondering, those images are indeed Pixar inspired, which is exactly where Pat is heading next.
At Pixar, the main guy was this guy, John Lasseter, was an animator. So he was pushing more like the animation aspect of it. He was a great storyteller, worked at Disney. And so he was pushing everybody. For one story there's this one particular Pixar film I worked on a little bit called Luxo Jr. I don't know if somebody may have heard about it, but it's this like Luxo lamp. There's a little baby Luxo lamp and a mother Luxo lamp. And they're sort of like the baby Luxo lamp's jumping around like a kid and causing all sorts of trouble, and the mother's just watching it. And it's just a very charming little movie. But the reason we did that movie was we invented a new way of casting shadows. So we had this really specific technical thing, which is cast shadows. And John Lasseter says, "Oh, let's make a movie of this baby Luxo lamp," And then of course, the Luxo lamp is like moving really fast, and every time it moves its face, the shadows are moving like crazy, and we were really worried the shadows wouldn't look right, if they were moving. And so he just dreamed up this really, imaginative animation, which we used to, drive the development of the shadows. So it just, the artists were, there we had developed the algorithm, we knew, but he just sort of very creatively used it. And nobody knows that that's why we made that movie. I mean, it's a pretty nice, it's a little short 2-minute movie or something, but, that's what, he would just, drive us, and then, we'd have to make sure it worked.
No, it's fascinating that, as you say, that was like a very creative way to test out the software and the new.
If I was going to do it, I'd maybe have a rotating cube.
So you need the
You know what I mean?
So did you have like that artistic, creative element? Like in your, is that kind of what drew you to computer graphics?
No.
Or it was more,
I was definitely came from the technology side. Yeah.
Okay,
But I had a great appreciation for art. I liked art. I was really like art history classes. I used to go to art museum. I did some drawing and stuff, but I'm not a particularly good artist. But actually, one thing at Pixar too, we didn't try to look for they used to call it like Renaissance people, that were really good at not like Leonardo da Vinci, right? I mean, we didn't have any Leonardo da Vinci's there. We tended to have people that were good at one thing. Like I was a good programmer and I knew a lot of physics, and so John Lasseter was a good animator and he knew how to tell stories, and so on. And so everybody, tended to specialize a little bit. But what was common was you had this real appreciation for all these different, talents that people have, So one thing we did, which was really cool, was we like the technical people would take a drawing class and have a art show, where all their drawing, that terrifies technical people. I mean, you say make a drawing of me, and you're just going to be terrified. And then all the animators and artists would have to do a science fair project and have a science fair. You know what I mean? And it's just a simple thing, but everybody, at first maybe, the two groups would look at each other from afar and not quite understood what was motivating them and what the value of their talents were. But once you do something like that and you appreciate what it takes to be an artist or what it takes to do something technical, then you just appreciate people. And so that's sort of my like, I just have an appreciation for all these other aspects of things. And that's all you really need. You don't have to become an expert on it, I don't think, but you should really appreciate what everybody brings to the table. That's how I felt that.
Absolutely. Absolutely.
Yeah.
So what was it then that drew you to computer graphics? So I'm thinking here, was it you were at Madison?
I was at
Wisconsin,
University of Wisconsin-Madison.
And you were doing PhD?
Yeah, I was doing a PhD in biophysics, actually.
Okay, right. And
I was studying the neurobiology. I was neuroscience. I was studying the neurobiology of nematodes. Okay. And my advisor worked in this guy, Sidney Brenner's lab, UK guy, won the Nobel Prize. So he was working on this organism called C. elegans, which is this little free-living nematode that lives in soil. And it was a very simple organism, and it only had like 450 neurons in its nervous system. So, and people had figured it out, the entire wiring diagram. So we were working on this parasitic nematode that lived in pigs, which was about that long, but we could do certain experiments, like we could measure the voltages in the neurons and stuff like that, which they couldn't do in the really little one. So I was doing that, and this guy sort of recruited me, I think, because he thought I could write programs to simulate this motion. And so I didn't really know how to program, but he sort of expected me to write all these programs. I was a physics major, and so I taught myself programming. But so I started doing the simulations, but then I just sort of realized I'd have to see the results. Like I wanted to predict the wave motion of this nematode moving. And we were also doing a bunch of microscopy, and so I was trying to visualize they would do these slices and look at these microscope slides, and we wanted to build 3D models of them. But anyway, the long story is, one day, my roommate actually, he tells me that, this got this new graphics terminal in space sciences, and there's this thing, it's a frame buffer. And I said, what's that? Well, there's just this 2D array like you have in C. Oh yeah, I know what 2D arrays are. But whatever you put in this 2D array shows up on the screen. I still remember this. And I don't know, I just thought that was the most amazing thing. And so we go in, we start hacking programs, we just write these little C programs, and we start setting the colors in this 2D array. Really easy to do, and we could just see everything we were doing. And that idea of just making all these ideas that I was learning about concrete by being able to see them, and actually the first program I wrote of any significance was my first paper was, I wrote a program that you could type in an algebraic equation, actually one I did was x squared y squared plus y squared z squared plus z squared x squared minus xyz equals 0. Okay? Now, what do you think that looks like?
Oh, God. That's the question. Some kind of, it's going to be like a sort of squashed, I don't know, 3D thing. Not a sphere, but stretched and pulled in different directions.
Yeah, it's sort of like a threefold heart. It's sort
of, okay.
So you're actually very good at that. I would have never been able to say that. So you're actually a mathematician. But anyway, I wrote a program, and I figured out that what you could do for each pixel is you could generate an array, which is x equals x0 plus x1 times t, and y equals y0. Basic parametric line equation. Substitute that equation into that equation of that surface. Now I have a univariate equation in t. If I solve for the root of that equation, where it's 0, that's where the function is 0, right? The values of t. And so I generate an array at a given pixel, solve for the roots of the thing, and I could draw the sphere. I could draw the surface. That was my first paper. And so I can show it to you if you want. I'll send you it and maybe you can insert it. But yeah. And then, so I could suddenly see this surface, and so I was just sort of enamored with this idea of taking, any concept, any mathematical idea, and be able to see it. And it just felt very different to me. I don't know how to describe it, but to be able to see the surface and not, I think mathematicians probably could just visualize it, but I couldn't just visualize it myself. So anyway, so then I just started, doing all sorts of things where I just write all these programs and make pictures of things. And it was mostly visualization. I just wanted to, started out doing a lot of math viz, but, eventually I, was trying to work on my thesis. but then, I sort of got seduced by computer graphics, because there was, in computer graphics, you have to realize this particular frame buffer that I was using at the time, this is like 1980-ish, it was like 512 by 512 by 24 bits. It cost like $250,000. It was in the 13th floor of the Space Science Building, and they were able to buy it because they had a satellite dish on the roof, which was receiving weather satellites. So this was not like something that most people even knew about, much less had access to. So it was really, computer graphics was just literally coming into existence. We certainly didn't I actually taught the first course ever at the University of Wisconsin on computer graphics as a grad student. So it just didn't exist, and it was just like wide open. So once, that was even more encouraging, because like everything you worked on was brand new. You know what I mean? It's
no, absolutely.
Yeah, and it's just, physics and biology was much more of a, more of a slog. Like if you're in this unexplored territory. Just everything you do is new, and that's just a really exhilarating feeling. So I just got seduced by that, and then I eventually ended up at Pixar, and because there were just a very few people in the world working on it, to be honest. I mean, at that point in time, it was so rare.
So you're borrowing the Space Science Institute's computer, doing all this stuff, and then you mentioned you then went to the New York Institute
of Technology.
Now I was just
it's not MIT. It's the New York Institute of Technology, which nobody knows. I mean, nobody.
Well, I was doing some research, and it claimed that the building was a converted garage, two-story garage.
It was on the school was on this old estate in Old Westbury, New York. And it was like a studio garage. It was like a carriage house kind of thing.
So the draw there was a real opportunity to move into graphics. In terms of like thinking.
So the way I was learning it by myself basically, because nobody else around me, and I was reading papers on computer graphics. I just started noticing a bunch of them were coming from this place.
Oh, okay.
So this place was sort of crazy. I mean, one thing about computer graphics, there were these sort of like crazy, millionaire types that sort of funded it in the early days. So there's this guy that was the president of New York Tech, and he wanted to make an animated cartoon called Tubby the Tuba.
Right.
So, and he thought he could use computers to do this. Pretty amazing because so he hired all these people in computer graphics. Basically hired everybody in the world, and nobody could get jobs anywhere else, and he just hired them all. And he had so much money, we had like 55 of these frame buffers and stuff like that, at New York Tech. So I realized that this seemed to be the center of the graphics world.
Right.
And I got myself a summer job there somehow. And and then I sort of left. Actually, I left school before finishing my thesis, and spent like about 3 years there. But then I came back and finished my thesis. But it was just a crazy place. I mean, I could go on and on about it, but it was a really amazing place. And so then I started really, then I sort of got inside the graphics club, and I learned all the secrets and all that kind of stuff.
So then, how did you go from New York to Pixar?
So what happened then was the main people Lucas realized that they were doing all this amazing stuff. So and he was really interested in technology, and he sort of lured them away, and they set up the computer division of Lucasfilm. So this is sort of post Star Wars. And so, and he really liked special effects, and he invested a lot in technology because doing all these special effects. So they set up the computer division, and there was a computer graphics division. There was also a video editing division. They wrote some of the very first video editing software ever. There was a big sound, division. They did a lot of sound work, audio work, and that kind of thing. And so, the sound and video editing actually very quickly became useful, in the movies. But the graphics stuff just took a little while because we couldn't really do anything. But so they had a very small group. But he didn't really necessarily believe in it. Like he really never used it in any major way in a movie, and he didn't really want to make a full-length computer-generated movie,
right?
Because he did all these live-action movies.
Yep.
He liked to insert special effects, but he wanted to do the live-action. So Pixar sort of spun out of that because they wanted to do a full-length movie, and they wanted to grow, because he wasn't using it, they couldn't grow. So I sort of joined them. So the people that formed that company were all these ex-New York tech guys, and we were in this small group. I mean, you're talking about like the whole computer graphics world is like 40-ish people at that point in time. I mean, so we got to know, everybody got to know each other, and so that's how I went there.
Okay. And then there were various sort of, at least on, let's say, the global scale, sort of smaller movies, successes, as you said, trying out jumping lamps to show shadows. So then so I guess, at least from my memory, like Toy Story is the big breakout.
Yeah. So
I remember
that's
watching
like,
that as a kid. That's
right. And that's 1995. So that's sort of 15 years after, when I started working in graphics. And, it just took a lot of time. I mean, graphics is like simulating a virtual world, right? You have plants, you have clouds, you have rainbows, and people, and cloth, and hair, and skin. I mean, and then you have to have a system that can do, our system was called RAISE, which stood for Renders Everything You Ever Saw. So a lot of what we worked on was like how to create a system that could make a sort of like you just look out this window and you say like what's out there, and we have to be able to make a picture of that thing. So it just took a long time. That was just a few people at Pixar, but all these people started getting interested, and they would figure out how to do all this stuff. I mean, literally hundreds, thousands of people would start working on it with this sort of goal of making a full-length computer-generated picture. And
so that was the goal. That was very much like we've done all the shorts.
Yeah, that was like the moonshot.
Right, amazing.
Right? Yeah, and it took a long time. And part of it was just computer power, because we would calculate how much it would cost to compute a movie, and it would just be like one of the first shorts they did on a Cray supercomputer, that they had to beg to get access to. So, it was sort of like biding our time. So I mentioned that like there was these benefactors, like first Lucas, that funded this research for many, many years. Then when Pixar was acquired, Steve Jobs acquired us. So he funded us for many years. I think they spun out in 1986. And so, that's another 10 years before they had their first movie. So he spent almost all his money on Pixar. I mean, he just kept, piling cash into it. So it was interesting because it was a long-term vision. And it was sort of synchronizing the rise of computer power with the development of algorithms. So it was sort of good that the computers were a little slow because we could just work on the algorithms. But then what happened was, there's like when you have these exponentials, once you sort of cross, then boom. So like what happened so I worked on this system called RenderMan, which was our way of making pictures. And it was sort of used, it was used in a few movies like Terminator 2 and Jurassic Park. And these were movies, and Lucas sort of talked them, and I think John Cameron, Steven Spielberg into using, the technology. But then those were like blockbuster movies at the time. And so suddenly it went from like, nobody even knew about it, to the biggest movie of the year was had dinosaurs made by computers, or the main character, one of the main characters, Terminator, done with computers, and then just takes off, and suddenly a few years later, almost all movies have some computer graphics in them. So it's really it's an interesting story. Like you work on things, and then suddenly, it's like AI right now, right? Like people have worked on it for many, many years, and then there's this transition
Suddenly,
point,
yeah.
and then it just goes crazy. So yeah, so that sort of happened. So I didn't actually think it would happen in my lifetime, but it did.
Yeah. and you've since received 3 Academy Awards
Yeah,
as well,
yeah,
right?
yeah,
Which
yeah,
is,
yeah.
I was looking this up, like, surely there is nobody else with a Turing Award and an Academy Award.
I don't think so.
That is,
yeah.
like, you know, they talk about is it like the Grammy, the Emmy, the Tony, and the Academy Award.
Yeah,
I feel like they should add academic prize into that group.
These are technical Academy Awards. They're not for acting or anything like that.
No, but I still,
but it was fun. Another funny story, like I go to the first time I got an Academy Award, this person's hosting it, and when they say, "This is Sharon Stone," and I look to my wife and says, "Who's Sharon Stone?" I mean, so we're nerds, you know what I mean?
Of course, yeah. You're in your own little world, like, yeah.
So but it was a little.
Did you still, I assume, they still have like an appreciation of just how, I guess, crazy it is that you are, in your own words, part of this group of nerds who are doing computer stuff, and suddenly you're at the Oscars getting an Academy Award?
It was very weird, but it was fun. It was like giving those demos. I mean, but you have to realize computer graphics is an extremely technical subject. You know what I mean? It's like, really, another thing I worked on was like GPUs, because we were so limited by compute power that, actually one of my students sort of designed CUDA, actually, which is what NVIDIA uses. But we were so limited, working on programming languages and computer architecture. I mean, that's like hardcore technical stuff. Then there's also like the math of surfaces, and, a lot of what I worked on was Monte Carlo techniques for computing lighting. It's really cool, lots of cool math in it, and it's super technical. So, it's not just all like fun and games. It's like, people, they think it's magic, it's almost like too fun, and so people don't think there's any depth to it. I've had many people just think there's no depth to it at all, and then they read some paper and they're just amazed at, the math in the paper.
So, on that note, what was some of the hardest technical challenges? So, for example, I remember speaking to one of my colleagues in Cambridge, and he had done some sort of consulting work around hair movement in video games.
Yeah.
Because apparently it's like a fluid dynamics problem, which was my research area.
Exactly. Yeah.
So, and then, and that is
moving. Exactly.
Apparently that's still a very difficult thing to have hair in a video game setting that looks like hair would move.
Absolutely.
So, are there any other kind of?
I mean, I actually worked on rendering hair, so it looks right. Yeah. And I worked on rendering skin. Those are probably. My second Academy Award was for rendering skin.
Right.
And the observation was that you had to model light going into the skin and bouncing around under your skin. So most of the light the appearance of the skin is due to light going into the skin, right? Like if I look at your lips, they're red because I'm seeing the blood beneath or if you're blushing, I see through into the blood vessels, what I mean? So you have to model light going in there and then getting scattered around and coming out. And the same thing happens with hair, hair, if you look at it, it's like this sort of dielectric cylinder, and the light actually goes in and sort of refracts through it, sort of like an icicle. And so you have to sort of model that, So, I mean, there's just all these little neat little, for me, it was really good because it's sort of a combination of like physics where you have models of things.
I was about to say, it sounds like
it's like physics,
that kind of background and knowledge you have. Maybe you didn't quite realize at the time.
I didn't realize at the time, but that turned out to be really huge. Yeah.
Because again, I'm a complete novice over here, but like I would have just assumed, as you said, talking about skin and hair, I would never have thought that you would have to model the light coming in, bouncing around. I would have just thought it was just to do with external lights or to do with certain shadings or pixel definition or whatever.
But you have to figure out, how it reflects the light and why that particular thing gives it. And as a result, your skin looks sort of soft, like if you look at baby skin, and you see into it, actually, I was inspired by Rembrandt because he would paint things with layers of paint. And he would be very famous portraiture, right? Yeah. So he sort of discovered this, but he could fake this by layers of paint, you know what I mean?
yeah.
And that was actually how I started realizing that it was a subsurface thing. But a lot of it was like looking at the world, like everyday world. You know, I mean, like physics now tends to be at work in very esoteric domains, like, you know, quantum mechanics or, you know,
String theory.
String theory, exactly, which is cool. I mean, I love it. But, you know, there's surprisingly little known about the everyday world. Like, you know, why things look the way they are, or not just look, but, you know, why the motion is the way it is, why a cloud looks the way it is, you know, why does water look the way it is? Why does food look the way it does? I mean, you know, and so, you know, I just was fascinated with those kinds of things. And then, you know, then you do standard physics stuff. You come up with some model, some approximation, some phenomenological model. And then what we do is we use ray tracing to implement it. That was my third Academy Award, but just figuring out how to do the lighting, you know, when you have billions of objects with really complex properties, and how does light bounce around. So so it's a modeling and simulation problem of the everyday world. Yeah.
And just a quick follow-up to that. So did you already see the world in that way before you got into this on some level? Or was this very much you were embedded in this computer graphics world and realized the importance of everyday objects, and then you began to, that was how, you know, the way you viewed the world began to change because of
definitely.
the computer graphics environment? Okay.
I think so. I mean, I was a physicist.
Yeah.
So I certainly knew about Lord Rayleigh, and I think I even remember that paper, why, you know, and he had lots of other, you know, interesting papers. And I sort of like classical physics, but I also like modern physics as well. But I think I got more focused on the everyday world when I got in graphics. And then because I had this physics background, that was, like you say, really helpful, you know?
No, it's like the perfect, the whole story is
just luck. Yeah, it's just luck, you know?
But also you had the perfect background, interest, the passion comes through, you know, you're telling this story now. I can tell you're still fascinated by these things. You're still thinking about these things.
I still think about them.
As we look around the room.
And also, you know, what I tell sometimes people, you know, they spend a lot of time trying to figure out what they want to do, but as you try to figure this out, you learn all this stuff, you know. And I spent all the time in physics, and then eventually I started disappointed that I wasn't going to become a physicist, you know, or a biophysicist. But then I found this other thing, and I was able to do what I did because I spent all this time learning about something else. So your life, you know, you just accumulate, you know, you get a very specific point of view based on your experiences. And then I think the way to be successful is to find the opportunities where what you know and what you can do is relevant. And that's, you know, I think that's a good general strategy. And, you know, the more you learn, you might think you're wasting your time, but you're actually like creating yourself. And then when the opportunity comes around, you'll be this unique person that can do it. So I think that's how I view my life. That might be a rationalization, but you know, it took me a long time. I learned a lot of stuff, and then eventually, like you say, I just got the perfect match. You know, and boom, you know, that's.
I think that is a fantastic take-home message for the viewers to end on. That is absolutely brilliant. So it's been a real pleasure.
Yeah.
I knew it would be, but like,
it's awesome. Yeah.
It's as I said, your passion, the way that you view the world, it really comes across when you're talking about
That's
this.
good.
And I think that I hope we've managed to capture that for everyone watching as well, because I've definitely felt it in the room. So again, thank you so much for sharing those stories and talking with us all. Thank you as always to the viewers for watching. Any of the stuff that Pat's mentioned, I'll link in the description, and also the Sparks talk you did this morning. We'll also put a link for that so you can hear more about what Pat was doing over here in Heidelberg. But again, Pat, thank you. Thank you, viewers, and I'll see you next time.